I had made reference to the Ghana Building Code. And in the Ghana Building Code, out of the 38 chapters, you have 9 thematic areas. And there's a thematic area group 7. It's made up of part 19 to 27. That covers 9 main types of building materials. And the first one is unknown, new, innovative, and versatile material. Used in Ghana such a material shall be subject to prior inspection, review, test, etc., and approval by GSA. That is exactly what was done for Viva. So, in the other 8 traditional materials, it is also saying that those materials, you should also see what you can do to improve the properties cement. There is a publicly available specification on that. The LC3 is limestone calcined clay cement, which reduces the clinker content, the clinker that we have been importing all the time, reduces the clinker content between of the RC440, And most important, a few topics are not addressed or not applicable. So, chapter 12 on diaphragms. If you are doing structures, you know what are diaphragms structures. Chapter 14 on plain concrete, it doesn't apply to plain. Chapter 17, anchoring to concrete, it does not apply. Chapter 18, earthquake resistant structures. And chapter 23, strat and tile models. Those of you reading this, go and find out what that means. So it also talks about the key design differences. The key design differences for the manufacturers, known as what uses an environmental reduction. Yeah, okay. Just because of the non-corrosiveness and the rest. Okay. Yeah. So the design differences continue. The lowest length for specify the length based on the required. That one to have been given to you by Professor Kankam in detail. Compressive strength, low shear, susceptibility to fire and smoke production, high coefficient thermal expansion. That strength elements from the self element to the durability element and the rest. They are still under construction, and I'll get it peer reviewed by seniors like in the literature. They say that the bond strength is low, but here once Viva has improved the surface, the bond strength is rather higher. So we need to agree what is our reference point. So we have the examples of application in Ghana. This is a 7-story building. Like I was mentioned, because of the lightweight structural requirements. That's the Pokwasi interchanges. Some jetty repairs at the Tema Harbor.
Assess remarks, and then we call it for a day. So the floor is open for your questions. Yes, I see one here.
Hello.
Okay, raise up your hand. 1. Okay, 2. and then 3 and 4. Okay, and 5. All right. So let me start. What was the first hand? Okay, give it to him. Yes.
Thank you. Thank you very much for
Yes,
the
Prof.
opportunity.
Engineer. No, don't worry. You can stand wherever you are.
Thank you very much for the opportunity. I'm Apia Gideon Cranton, an electrical engineering student.
Okay.
Please, my question is with the metals, the fiber it's in place. So I want to know if you have the material, which is the fiber, can be the material, which is the fiber metals. Do we have products like the tying rod, the metal one, that could be used to tie it? Because like we are using the steel and the fiber metals differently to create like the skeleton for the pillar.
Okay.
And also, I want to know if engineers, that civil engineers or structural engineers, have been able to create a system to measure the lifespan of materials used in building and to predict days of the dead point of the materials so that plans could be made to control. Plans could be made. Let's say in the next 10 years, this building may suffer from cracks. So there's a measurement system that maintenance would be made to support that building. And also, with regards to the question the gentleman asked over here about sensors and measuring instruments to measure such leakages, breakages, or collapse, that there should be partake in creating a system or device to measure the strengths, the collapsing. And
let's clap for him. Come on. Let's clap for him. So I think this question is on 2 ways. Dr. Tina will answer one, will answer one, and then engineer will answer one. So I'm throwing it to you in terms of what the faculty will want to do with this particular question, and then engineer will answer it from the point of engineering, and then engineer Seth. But Ivan, I think one is related to you concerning the tiring. So
GISS recommended. And then when Viva came in with the sandblast coating, we realized that that was no longer necessary. I think Ivan will explain that because we, during the review, said that so while you are going to use steel serifs for the beams, bond strength, that's on that. On the issue of I think that the non-metallic and versus steel, yes, that covers for the interaction between the steel and the fiberglass. Thank you.
Yeah, HOD, the question of the department.
Okay, so we will try and find a way to. So there's more of instrumentation and electronics and structural loading. We will find a way to collaborate. We are all here, so you don't worry about that. Okay, you are in electrical what? 2. Okay, that's encouraging. Yeah.
Professor.
One aspect of the question was on durability. Maybe I'll address that. The durability in civil engineering, structural engineering, we are concerned with durability, and then the age. Because all parts. Because when you design something or you construct, we have what we call the lifespan. It's a lifespan. So your design, your construction, to be able to meet, we go beyond it. And when it comes to durability, there are so many ways of checking durability. We monitor, we do social monitoring, right, to see whether something is going wrong, the material. We have the serviceability conditions, cracking, different stuff. What we're talking about, concrete, reinforced concrete, even structural steel. We look at all these things to check. But one advantage of the GFRP is that with the corrosion, it's corrosion-free, chemical attack-free, and a lot of free, right? So the durability aspect, right? When we're talking about, it's an advantage. We are less concerned about durability of it. And when you're talking about serviceability of GFRP, it's not about cracking per se, it's the deflection. The deflection in terms of serviceability mistakes when you are doing that design. So durability, glass fiber, its durability is on the high side, not much problem. over there. No, something losing durability. In a poor country, Ghana, the sensors are not there. So it's a very good thing for electrical engineering, electronics engineering. That collaboration is essential. Come out, study the various sensors and help the structural engineers.
That's very impressive. Ivan, would you want to say something regarding the? He was asking of the
Yeah, with regards to the ties, engineer says almost answered your question, but the main answer from business side is the cost. We structure engineers, when they are advising and consulting their clients, they are not to advise something which will increase their cost, long term and short term, immediate cost and long term cost. So there should be a combination of efficiency, and that's why Viva has introduced the hybrid approach in order to help to save the cost. And that's what I will tell later on when I'll be closing up the business aspect of it, which I hope everybody will be interested in.
Then in that case, then would you want to close it up and then I ask the question, or I should ask the question and then we close it up? Okay, the question is, I saw another hand. Which other hand? Yes. You were number 4, but who was number 2? Okay. No, yeah, I think there was a lady there. Can the microphone be given to the lady there?
Sir, please, how does cyber enforcement, how does it perform in extreme weather conditions such as earthquake?
Such as earthquake, okay. Yeah, or earthquake.
Yeah, that has already been mentioned. Even in the RC code, it doesn't apply to earthquakes. And like Professor Kankam said, earthquake, the reaction is
no business in engineering construction becomes designers. And so if the enforcement is not done well, we will end up having everybody using it, but not using it right.
Right, yes.
The other question is that whilst we are introducing this material, we have people that must approve.
This is a two-way question. Engineer segment
or deputy chair of the Ghana Building Regulation, which was passed by Parliament in 2022. In fact, we started that process in 2019, aimed at completing it in 2020, but then COVID knocked it off rail. So in 2022, it was revived. So we have to meet the Parliamentary Select Committee on Subsidiary Legislation for that legislation 2465 to be passed, because you have to defend whatever you are written. 65 to be passed, because you have to defend whatever you are written there. The problem of enforcement has always been there, and the Parliament was also asking, how are you going to make sure that these things are enforced? And then in the regulation, we introduce independent inspectors. And then we also make provision for the fact that if an MMDA, who are the regulation, have a challenge in terms of a specific, it is to help you in doing the assessment. And that is why it is also insisted, both in the code and the regulations, that every base must be section. This, what do you call it, independent inspector, or even the assembly itself. If you are factored in all those stages of going to check transport, motorbike, whatever vehicle, fuel, transport, motorbike, whatever vehicle, fuel. If you are factored in all those in those stages, you have enough money to resource yourself to be able to work, inspect and enforce. But there are saying, there's always argument on platform that, well, you give us the resources and we'll do it. Meanwhile, you are limited. Even if they give you the resources, 2 or 3 assemblies in the same contiguous area can combine and get the service rendered. But we are refusing to take that.
I see. That's a very interesting thing. Ivan, would you want to say something?
Yes. We are living in 21st century, and just this morning I was watching one video. I tried to find the approach of not manufacturing the material. We are a service provider, and we provide a full solutions, engineering solutions. We partner. We have signed the MOU with Ghana Institution of Engineering 2 years ago to develop an express course where engineer says such big people like engineer says or Professor Kankam or big people like engineer Bempong or other people are engineering. And the person buys because it's cheaper. This is also a big challenge. And this challenge is much bigger than asking yourself what is the durability and who knows what is the lifespan of iron rod here.
Yes.
Yes, please.
The lifespan, he is saying the lifespan of iron rod is 50 years.
Thank you very much. Who knew this information apart of him from this students, including students of civil engineering? Very few. Just imagine how many people know this information outside of technical universities who has higher degree in structural engineering. But all people, they ask, what is the lifespan of fiberglass? The lifespan of fiberglass per the ACI code is 100 years without servicing. But am I lying to say that the 50 years lifespan is provided there is enough sufficient servicing and maintenance of the building? Correct?
Yes.
Yes, thank you. So that's why we here as manufacturers of fiberglass, we provide a full solution to those who want to achieve maximum efficiency of those materials which are available. Currently, cement is not only cement. There are various types of cements. When people are using the word, let's mix cement with sand and chipping in order to get the concrete, only professionals, and not even all professionals, they know the difference in different types of cements which is available here in the market. The same as type of reinforcement. And that's why we are using hybrid approach. When we mention hybrid, we don't only mention fiberglass rebar. There are so many types of reinforcement. Even iron rod has different types of iron rod. Moreover, there are so many limitations of iron rod, which most of people don't talk, especially in terms of quality. When you try to check the quality of iron rod, this approach which Professor Kankam mentioned of under reinforcement is very critical in Ghana, because when iron rod is tested, it's tested on the minimum tensile strength, on the yield force, but is never tested for the maximum, and people don't take care when they use, let's say, mild steel. The approach of non-professionals is the stronger is better. Instead of, let's say, putting 12 mm, let me use 14 mm. It will be safer, and they don't understand going to face when you come out. And we as manufacturers, we support such people who want to face the challenges. We are there to answer technical challenges. Engineers, Mr. Kwabena Bempong, he was one of the first people who practically used this material in Ghana in 2018. He also introduced this material to other structural engineers like John Ankra in Kumasi, who also brought the same material to Professor Kankam to study, because these big people, they really brought the challenges to the level that we need a scientific research. We need academia to start delivering disadvantages. And as you have seen, we are not talking here much about advantages of fiberglass, because that one everybody can get everywhere in the internet is spoken. But limitations is very important. How many people from iron rod manufacturers are talking about drawbacks of iron rod? None. So as a matter of fact, I will come back to the opening of this ceremony where it was said that fiberglass is more a fact enforcement into strength. You don't need the strength. You don't need to give you funding for some solutions. If the resource is not available, find it yourself. It may be lying down just under your feet. That's the best approach. And we are there also as manufacturer to help you and assist. The first presenter of this at this lecture was also a student who was looking for a support of price for the maintenance of buildings. It's very needed approach and very needed.
Viva and Enrico, we are those in the industry. We have 3 levels: the basic, intermediate, and then the advanced. Now, the masterclass seeks to uncover certain gaps when it comes to the areas, design it, and then how to use it. I hope you're getting it. Great. We had the last hand. Okay, the last hand. Your hand was up. You are the last person. Hey, I'm seeing more hands.
Yeah. Yeah, okay. My name is Richard.
Let me take 4. This one's hand has been up. Oh, yes.
Yes, my name is Richard.
1 minute.
Yes, I want to ask, as a private developer, and then knowing about all these kind of reinforcement, if I want to develop around a seashore, maybe at a beach, which reinforcement method will be best for me?
Okay.
Because when they were explaining, they made mention that the hybrid system combines both the fiber and then the steel as well. And then we know that the steel corrodes with time. If I'm using that method there, is it going to work for me? Or how long will I wait for the fiberglass to be able to help me from scratch to finish?
Okay.
Thank you.
Okay. Ivan wants to answer before Prof.
You see, once again, is about economics and the serviceability of buildings. For how long and at which extent do you want it to be absolutely non-corrosive? Are you ready to pay higher price? In this case, we as a manufacturer, we can manufacture stirrups and rings, as it was mentioned before by Professor Kankam. The question is, are you ready to pay 10 times higher the price for compression reinforcement? Or you want to combine, let me change the rings in 5 years, but still I have some 70% of non-corrosive reinforcement. So it's all about combining the resources. Yes, now I'll give the answer to.
Yeah, I'll tackle it from this way. Some of my finding, the study were about the possibility of using GFRP stirrups. Right. So the hybrid approach, one of the recommendations perhaps they say use the main bars are GFRP, and then from the past we have known that the GFRP, for example, if we just want to use only the GFRP without the stirrups, because in the corrosive prone area, very prone area, like recently a student of mine has done work on the Accra Community Center. Structural integrity assessment at Accra Community Center. Is it near the AX center? Near the AX center. Very, very severe corrosion area. Every system, just check if there's possibility of using the stirrups, GFRP, use it. But let's say in compression side, on the compression side, you still want to use the steel. On the compression side, you don't have any problem with corrosion. Right. On the compression side, the concrete member
said that in the RC code, they didn't talk about that. The areas that the strength is low, you have to use more. I mean, if you are doing your calculation, it depends on the strength you are using. So you can still use it, but then you have to realize that you have to use more in that situation. But then you have to realize that you have to use more in that situation. But then the hybrid approach comes in that, okay, fine. Since the rebar, the steel is better in compression, then you use it. Is better in compression. Then you use it. If you don't have a problem, you can use only the hybrid, but then you have to use it more. It's a matter of using the strength to determine the area that is needed.
And that was the last question. But no, yours, okay?
Ibe Emmanuel from Civil Engineering.
Okay.
My first question is concerning steel structures.
Okay.
So we don't, in developed countries, we see high-rise buildings,
Yeah.
and we notice that from the foundation, only I use the FRP for the foundations. And the next one is concerning durability. If FRP is very durable, that's it lasts longer. But concrete doesn't last as maybe it might last. After
That's a very good question. Prof, would you answer that?
Yeah, right. Good question. But in my presentation, I start glass fiber. If you look at the therapy happens in most of the distance, it has. So we are doing research on that. After testing the concrete failure, it's very important. That right. So it's very important. That right. He's talking about sea bass, but the pair, your concrete, compassion, and so on. Your concrete, compassion, and so on. So you have to make sure that your concrete is well designed and constructed. Then you have to make sure that your concrete is well designed and constructed. Then you are sure of having very durable concrete. But if you prepare your concrete and the concrete will not last. And then
All right. Oh, I'm seeing more hands, but I think that we need to call it off. The questions are up. Ivan, please you can write the questions down. We'll announce you can send the questions on our platform, and then we'll take, or you can give it to your departmental heads, your HODs, and then we'll answer them on our platform. WICO has a very large platform where we have series of engagement, and these questions are going to be answered at that platform. At this juncture, I would like to call on Mr. Ivan to give us the remarks. You are done? Ladies and gentlemen, we want to say a very big thank you to everyone, the Faculty of Engineering, the Department of Civil Engineering. Please, everyone should sit down. Everyone should sit down. And then we are grateful to Accra Technical University for having us. The last announcement I want to make to you all is that like I said, the Build Professionals Masterclass will be coming off, and then keep note, we'll send you the informations. When you hear of the Accra edition, make sure you come. And then also, the Viva-Industry is on a train to other institutions. So tell your friend in the other institutions that we'll be coming to them very, very soon. Yes. Yes. All the dignitaries, please, you are to go to the staff room. We have a meeting. All the dignitaries, please, you are to go to the staff room. And then if you want to be part of the student network of the RICO International, the links were there. You get the opportunity for access to our sessions, mentorship, internship, field trips, and all that. Thank you so much. Can we have the... Yes, faculty members are part of it. Please, faculty members, let's have the... And then we call it for a day. My RICO prayer chaplain is here, Engineer Samson.
Please, shall we pray? Thank you very much. When we finish praying, the sharing can still continue. Thank you. We give you all the praise, our Father. It is a great thing to learn understanding and knowledge in diverse ways. We pray and ask that, Lord, you help us to have open mind and be able to advance in our course of engineering and practice. We pray committing all those who spearhead this particular thing into your hands. We ask that as we champion it, Lord, let it be done. Our next years ahead of us, we will not experience collapses as a result of failure to do right implementation. We ask that you help all of us, give us the opportunity, give us the understanding, and give us the will to be able to apply. We continue to commit RICO International into your hands. Strengthen them physically and financially. We commit Viva into your hands. We ask for collaboration in terms of research to support their work, that one time our country will also become a good place to be a reference for future developers. Thank you in Jesus' name. Amen.
Please, before we go, let's take a group photo. Let's take a group photo. The dignitaries first. Please sit down. But for the dignitaries, let's take our group photo. I'm told some of the lecturers just came. Please, all the dignitaries here, let's take the group photo. Whilst the students, you sit down and you take your snap. But we want to take a group photo with all of us. Please don't go, please. We want to see you in the picture, please. Please, let's hurry up. Let's take the group photo. Simon, let's come. Please, let's come. Engineer Chef.
Civil 2, remain seated. Please, Civil 2, full time. Civil 2, remain seated. Civil 2, yes, I'm taking attendance. When the tides are breaking, when my things giving with you, I can't lose. I feel like a winner. I surrender my all. I'll give you my heart. Lord, you can have it all. I feel like a winner. Use me up. You're more than enough. That's not fair. I feel like a winner. I feel like a winner. I feel like a winner.